Hi everyone. We are now starting to develop our first microservice that will be responsible to get data from Twitter and put on Kafka. Alright, let's create a submodule for Twitter to Kafka service, which will be again a Maven project. So please remember to choose the Maven project on the left panel while creating the new module, so that IntelliJ will create the pom.xml file and the correct Maven source folder structure. I will name the project as Twitter to Kafka service. And then open the pom.xml file to add dependencies for Spring Boot starter and starter test. Those are defined by versions in base pom.xml file, and we will put them in the modules pom.xml without versions. Here Spring Boot starter is needed to start developing a Spring Boot application, and we add the starter test dependency with scope test since it's only required for test purposes. Next, we need to add Twitter4g dependency to stream data from Twitter. So we will add this dependency into the main pom.xml file with version 407 and create a version property in properties section to refer it from the dependency itself. Finally, we will use Twitter4g dependency in the submodule without specifying the version. We will use the same principle for the next dependency, which is Lombok, and it will help us to get rid of some boilerplate Java code, as we will see in a bit. So we get Lombok dependency with version 1.18.16 and define it in the main pom.xml file with the version, then add it to submodule pom.xml file without version. Note that Lombok is a compile-only tool, so that we use the provided scope here for this dependency. I will also add Spring Boot Maven plugin to create a runnable jar automatically for our microservice. We put these into the build section in the services pom.xml file. We can now create the Spring Boot application class as well as a context load test class. Let's first create a new package called com-microservices demo Twitter to Kafka service, and then create a class here, Twitter to Kafka service application. Then we will annotate this class with Spring Boot application, and then add a main method to call Spring application run method. This is the standard way of defining a Spring application class, and as I mentioned, running this class will start the Spring Boot application for us. Let's then add a package in the test folder and add a basic test class and annotate it with Spring Boot test annotation. Then add a simple context load test method with test annotation. This test class will run with Maven install commands and load the application context by starting the Spring Boot application. During build, it is helpful to see that application can start successfully. Okay, now since this service will not be triggered by a client and need to start reading data from Twitter when the application starts, we need to find a way to trigger the reading logic. To do that, we have different options. Let's examine them one by one and choose one of them. One way is that we can use post-construct annotation on a method, let's say with a method init. Now the code we write here in the init method will be called once, after the Spring being created. And by default, Spring beans are created once because they are created as singleton. However, we can actually change this behavior with scope annotation. Here we see the supported scope annotations for a bean definition in Spring. For example, if you set it to request, it will create a new bean for each request. So how many times the init method will be called then? It will be called in each request separately because the method will run after each object creation. That means for each request. So actually this is not a good option for an application general initialization job. Although this behavior is only valid, for example, for a controller, where a request will cause to create a new bean, I will still look for a better alternative for initialization. So let's try another option, which is implementing application listener interface and overriding onApplication event method. This is an application listener method, so it will only run once for sure, therefore we can use it. Here the parameter is application event for this method. There is also a third option, which is implementing command line runner and overriding the run method. This is also a perfect option for application initialization logic. The only difference with the previous way is the parameters. Here we have a string array as parameter. In the previous methods, the parameter was application event. Since we do not need to use the application event, let's choose to use the command line runner and write our initialization logic in run method. Note that there are also some other alternative ways to start initialization logic, like using event listener annotation, but I will stick to command line runner for now as it will do the job for us. Let's only print out something using system out for now here. Using system out, we can write down any text to console. Now I will add the application YAML configuration file to start adding some config variables to our application. Application YAML file is used to hold the application configuration properties. Spring Boot binds external properties from application YAML or application properties file into an application at runtime. We will add the keywords that we want to filter out the tweets from Twitter into this application YAML file. I will add a prefix called Twitter to Kafka service and add a config Twitter-keywords. And then add a list of strings like Java, microservices, Spring, Kafka, and Elasticsearch. So I want to get the tweets from Twitter related with these keywords that I defined in the application configuration file. To be able to use this list in the code, we need to match these values to Java class. And we do that using a configuration class. So let's create a new package config and create a class called Twitter to Kafka service config data. I will then annotate this class with configuration properties annotation and add a prefix, and this prefix must match to the value in the application YAML file. We also need to annotate this class with configuration annotation to make it a Spring bean. Then let's add a private list of string with name Twitter keywords here. The naming is important and this should match to the definition in the application YAML file. Note that for Twitter-keywords, we use Twitter keywords with capital K. So for replacement of -k, we use capital K. We will also use data annotation from Lombok here to obtain methods like getter, setter, and hashcode and toString to get rid of some boilerplate Java code. So what Lombok does is to create some code like getter, setter methods and then update the class with these methods during compilation, and the resulting bytecode that will be run by JVM will actually include these methods created by Lombok. Great, now I want to add logging capability to our service. And actually it's very easy, thanks to the Spring Boot. We got logback and SLO4J dependencies automatically. So we could only add a logback XML file here to customize logging behavior. So I will add this file. Here we define two appenders. One writes to console and the other one writes to a file. We can define as many appenders as we want according to our needs. In the console appender, we set only a pattern for the message. And in the file appender, we also specify a file name for logging. And again, a pattern of the log message, where we define the structure of a log message, such as showing the class name, thread ID, time, and the log level in the message. And finally, we have a rolling policy here to create a new file and compress and keep the old one after the file reaches to a certain size. Finally, we see that we can match the appenders to any package. For example, we set two appenders, defined here, to all classes that starts with com microservices demo package. That actually means that our all application classes will be logged by using those two appenders. And here the root logger will set the log level as a root which can be overwritten using a specific logger, as we did here. One more thing about logger is that we can actually define different log levels like trace, debug, info, warn, and error for our logger definition. And it will work like if you define a lower level, it will also print the higher levels. That means trace level will print all the log messages defined in the code. However, if you set the level as error, all the messages except error will be ignored. So this way we can control in the configuration how much log will be printed. For example, in production, you won't want to include that much logging, as it can affect the performance of your application because of I/O cost. Having the log feature, I will now update the initialization code we created in the Spring application class and use the logging framework to log the keywords we defined in the application configuration. For that, let's first inject the Twitter to Kafka service config data class into the main class using constructor injection. And then create a log variable for logging. Note that we set the current class name while creating the log variable so that it will mention this class name during logging. After that, let's log the keywords in the run method by replacing the system out with the log info call. Here in the code, we use info level, which was set in the logback.xml file. So we will see this message in the console. Then let's log the keywords in the run method by getting the keywords from config data object and convert the list to string array to print it nicely on the console using arrays to string methods. Now let's run a Maven install command to install the dependencies and to see if we have a successful build. Then let's run the application and check the console to see if we can print the keywords we define in the configuration. Alright, we see the keywords on the console. That's great. Now please stop the video and add a new config variable called welcome-message under the Twitter to Kafka service prefix in the application YAML file, and then set a message there to print it in the run method next to the keywords. I will be here to add this change, but please try it by yourself first. Alright, I hope you add this new config property and print it on the console. Let's do this change together also. I'm going to add new config to the application YAML first, called welcome-message, with a simple message like hello microservices. And then go and change the Twitter to Kafka service config data class and add a string welcome message property. Then finally, we will go to application class and print this new config variable in the log statement. Let's run the application again and see the welcome message in the console next to keywords. Before closing this lecture, I want to highlight some points for injecting objects in Spring. There are basically two ways to inject an object to another: field injection and constructor injection. Here I prefer to use constructor injection over field injection as it has some advantages. Let's first define the field injection here and run the application again. It should print the same results. However, as I said, there are some disadvantages of using field injection. So let's see what are the differences. First, you do not need to use auto-white annotation with constructor injection. So you can inject an object while you are writing a simple Java code without adding any annotation. One of the major advantages of constructor injection is that it allows the bean to be immutable, since you can define the property as final, and immutable objects helps to create more robust and thread-safe applications. Constructor injection also forces that the object is created with the required dependency as the constructor forces it. And finally, Spring doesn't use reflection with constructor approach, unlike field injection. And as you may know, reflection makes the application code to run slower since it involves types that are dynamically resolved at runtime. Alright, good job so far. I will see you in the next section.